In last video we have started implementing pattern manager class. This video we will finish the pattern manager class and the helper static class called pattern finder and all the strategies. So let's get to it. Okay, first of all I see an error. I think that there is a missing method or a method is called differently. So let's alt enter it and change to the correct name. Okay, with that's done, let's continue to our pattern manager class. We will start from implementing the constructor. Okay, and the constructor will take int pattern size and we'll assign it. Next, we need to create a method called processGrid that is a generic method that takes a generic value manager class, bool equal weights, and string strategy name. So let's implement it. By default, we will pass strategy name as null. So now we need to create neighbor strategy factory, create the strategy from our name, and create patterns. So let's start. First, we need to create neighbor strategy factory class. We will call it strategy factory and create a new instance of it. And next, we will call it to create our strategy. We'll call create instance. And here we will check if strategy name is null. A question mark. If it is, we will return pattern size, else we will return, and we need to create a string from it, else we'll pass the strategy name that we have received as the parameter, and at the end we will call create patterns method that will take values manager, strategy, and equal weights boolean value. Okay, so let's start from creating a placeholder for this method, and let's create a placeholder class for strategy factory. So let's go to Unity. In strategies, let's create a new class, call it the same as we have typed in the last script, neighbor strategy factory. Okay, let's get back to to the Visual Studio. Let's create the method inside our neighbor strategy factory. So basically, this method will be called at the start to process the value manager data. We will decide what strategy to use. We will get back to implementing what neighbor strategy factory does and the strategies themselves after we finish this class and the pattern finder class. So here we will call pattern finder get pattern data from grid and assign it to var pattern finder result. The pattern finder class will be a static class, and we will call on it get pattern data from grid. And we will pass it value manager, pattern size, and equal weights boolean flag. Let's keep on implementing this class. Actually, we need to create a placeholder for pattern finder. So let's do it. Let's go to Unity, and in patterns, let's create a new C# class called pattern finder. Let's go back to the editor and let's generate method. Pattern finder class will be used for finding neighbors and finding the patterns themselves. Let's just finish implementing this class and we will move to the pattern finder class. There is no good way to do it, so we'll need to just plow through the code. So let's go to next line and let's call pattern data index dictionary, which we have declared earlier, equals pattern finder result dot pattern index dictionary. Here we will retrieve our pattern index dictionary, so our pattern will be already mapped to the indices. And next we'll want to find the neighbors. So we will call getPatternNeighbor. GetPatternNeighbors, and we will pass it the pattern find the results and the strategy. And let's create a placeholder for it. We will have to change those objects types into a different type, but we will come to that. Okay, here instead of object, we will create a pattern data results class and return it here. So let's create the placeholder for this class. Let's go to Unity, create C# class called pattern data results. Okay, let's go back to the editor, and we need to update the definition of it. So go to the definition of get pattern data from grid, and here we also call this get pattern data results. Let's go back to the pattern manager, and let's alt enter this and generate property pattern index dictionary. Okay, so now the code looks much better. So basically this get neighbor pattern neighbors will call our pattern finder, pass it the strategy and our pattern finder results. So the pattern found in the value grid, and it will return us the neighbors dictionary. So let's do it here. We will call pattern possible neighbors dictionary, which was implemented before. It will be equal to pattern finder dot find possible neighbors for all patterns, and we will pass it strategy, and we will pass it pattern finder result. Okay, let's create the placeholder for this method. Okay, so let's implement some helper methods for pattern manager, and let's go to the pattern finder. So here we will need to create a method called get pattern data from index that will take int index and return pattern data. And we will return pattern data index dictionary and give it our index. Okay, great. Next we need to create get possible neighbors for pattern in direction, and we will be passing int pattern index and direction and return hash set of integers. So let's create it. And here we will return our pattern possible neighbor dictionary, pass it our pattern index, and call a method on it. So here we are returning a pattern neighbor instance, and since we have not yet implemented pattern neighbor beside creating a placeholder, it will have a method called get neighbors in direction that takes direction. So we can create this method, generate. Okay, so just two more methods and we will be done with this class, and we will go to implement the remaining ones. So another classes we need is get pattern frequency that takes index and return float frequency value. And we will return get pattern data from index and call frequency relative. So this method basically returns our frequency for a given pattern with the index. Next we want to do the same from frequency log2. So we will have get pattern frequency log2 that takes index and returns float value. And we will use the same method as above to return the frequency log2. And the last method will return the number of patterns. We will call it get number of patterns, which return integer value. And it will return pattern data index dictionary.count. So we need to return pattern data index dictionary.count. count. Okay, so that's it for pattern manager. Now we will need to implement the pattern neighbors and pattern finder classes. So I get the idea that we are going quite fast through this code and we are implementing methods that are not yet created, but I have tried to create the names that resembles what the method does, so you should have little trouble finding out what each of those methods does and how the algorithm works. So let's now move to the next class. Okay, so first of all, let's implement the pattern neighbor class. This class will be handling passing the neighbors. Actually, it will store the dictionary for direction and hash set of integer values that will represent neighbors in each direction. And for each pattern, we will have a pattern neighbor class instance that will store all of their neighbors in each direction. First of all, let's place it in our namespace and delete the monobehavior inheritance. Remember to leave the getNeighborsInDirection method intact. As I have previously said, we need a dictionary of direction hash set int. So let's create it. And we will call it direction neighbor pattern dictionary. Okay, now we need some helper methods to add to the dictionary. So we'll create add pattern to dictionary direction and int pattern. It will be the parameters. Okay, so we will take direction as parameter and int pattern index. And here we will check if the neighbor pattern contains direction. If so, we will add to the hash set. Else, we will create a new hash set with a single value. So let's create a check. Okay, I will need to return void. We'll call contain key direction. If so, we will add to this direction. Else, we will add a new direction and a hash set. And we will fill the hash set with our pattern index. So we are using hash set in this dictionary since hash set doesn't take duplicates. So we will know for sure that if we have our hash set, only unique indices are in it. So next we will need to create a method to get neighbors in direction that will take direction and return the hash set of integers. And it is here. We have created it earlier. So let's create here the logic. So if the direction dictionary contains key, we will return it, else we will return an empty hash set. Okay, we are returning the empty hash set here, since further this result of this method will be checked for if the hash set is empty or not. So that's better than returning the null value, because we now know that the hash set is empty in this direction. And the last method will be add neighbors. We will take pattern neighbor as input. So let's create the definition. Add neighbor. And we will look for each item in neighbor's direction. So this method will be used in one of our strategies. When we have multiple instances of the same pattern, it will create a new pattern neighbor for each of those patterns, and it will add those pattern neighbors to the existing pattern neighbors to create the general neighbors list. Okay, so we will look for each item in the neighbors direction neighbor pattern dictionary. Okay, and if our direction dictionary contains key, we'll add to the list If our direction dictionary doesn't contain the key, we'll create a new one. And if it does, we'll call union with, a specific method for our hash set that will create a union between the values of neighbors, the direction dictionary, and ours. So let's create the condition. So we will check if we don't have this key in our dictionary. If so, we will add the new key. Else, we will add to the existing key and create union with item values. So union with will add unique values into one hash set. Okay, so that's it for pattern neighbors. Let's get back to the pattern finder class. Okay, I will split the video here since there is a lot more code to be implemented. So we have finished pattern manager. In the next video we will look at the pattern finder class.